If you have a Honda 750, a Honda CB900 or CB1100, you are familiar with this sound. So you've heard the awful sounds that the starter motor can make on these Hondas, and it is the weak point of the CB750s, the CB900s and the CB1100s of the early 80s, and I'll explain why. So this is a starter clutch off a CB900, and this is the starter clutch off my CB1100. Both exactly the same kind of design, where you've got a gear here that's driven by the starter motor. The starter motor is always tied up to this, so it's always linked into this tooth. So this will sit and be stationary, whilst this thing will rotate with the engine all the time. But as soon as you want to start the engine, the starter motor drives this gear, which then forces this to turn. You can see that's locked in that direction. And as soon as the engine starts, the engine can run freely in this direction, and that's how it works. The way that these starter motors work is that there is a, if I take this off, it's probably the easiest thing. This centre section has got a spline through the middle of it, and that's what drives. This is always driven by the crankshaft, so this is always rotating. And then you have this brass or bronze plate here which holds these three cams. Now what happens is when it's going in this direction, you can see that this wheel here, this centre section of this gear here, actually pushes those back like that. So you can see there's no contact there. It's pushing it away. I can rotate freely, minimal friction. If you try and turn it the other way, the wheel digs in, that cam digs in against this shaft here and the outside of this brass or bronze piece here, and therefore it then drives through these three parts on here, which are then bolted onto the spring. So therefore when you turn this wheel, when this wheel is driven by the starter motor in this direction, it's driven through that block, through that thing, onto here, and it grips onto here, which means that this then drives the brass block, or the bronze block, keep calling it brass, and it drives this part here. The weakness of the Honda design is that these things here keep coming out. These are very loose, even from the factory. These were not Loctited in. They come out very, very easily. This plate will come off and will start rattling about. And what it does is it allows these blocks to move slightly. The other problem you'll find with these things here are sometimes this bronze bit here will crack and it won't properly support things. The other thing you'll find is that on some of these, that if I put this back on the top of that to stop it all from falling out, in the back of there you can see that this is the back end of where the spring loaded plunger is, and you can see here it's already started to, I don't know if you can see it properly, started to bow out. So sometimes what will happen is that when this is being driven, these things here will be pushed back in and will actually force this thing even further out, which means that you don't get the same spring force in this direction. So quite often when you look at these things, let's have a look at that one. Oh, this isn't too bad, but sometimes you'll see these bowed out. So if you get one of these, they're easy to take off. This will come off the top of that, but when it does, it means that all those things pop out. I'll show you that in a second. But what you can do is you need to make sure these are tight. Make sure they're tight, make sure they're Loctited in. I think it's about 20 foot-pounds is what you put onto these. Make sure that these are flat and that the bronze plate here hasn't got any cracks in it. And the problem that a lot of people have is that when they take this off, this part comes straight off. So if I do it like this, that is screwed onto there. So when they take this piece off, this piece slides out, and then those wheels actually come through and you can't get that one again. And it's a real pain, because what you then have to do is you have to take this all apart. You have to put that over the top, and then you have to push these wheels all back in all at the same time to try and get it over that central spigot. So that's how you can repair this thing. So you can make sure that this isn't cracked. You can make sure that the springs are in good condition. Sometimes the springs will break. They're very, very lightweight springs behind these plungers. I'll pull them out and show you. So there's the plunger. Very, very, very lightweight spring that can quite often break, and therefore you don't get the force that you need. or this plate here will buckle. So they're the common faults of this starter motor. You can see there's a slight different design between the 900 and the 1100. This is slightly lighter, it's been drilled, reduced some of the rotating weight, but the principle's the same, is that you've got these three parts here. So what can we do to fix it? The common fix is, if you can't get one of these, is to get a starter motor from an R6 Yamaha, and that's what this is. Well, this is obviously a crankshaft. So just move this back out of the way a little bit. In fact, what I'll do is I'll put it in one of these like that. So this is an R6 crankshaft. You have the generator here. It's on a taper, so you have to undo the bolt like this. Take your time. Undo that bolt. You can take all this off in one go if you're lucky, but because it's on taper, most of the time you'll have to give this a bit of a heat to encourage it to come off. There can be 3 or there can be 6 of these bolts that hold this together. Very simple, very straightforward. There we go. Put them over there. Lift that off. So I've got a crankshaft, I've got the rotor, the alternator, and I've got the starter clutch, which is a very, very different design. If you have a look at this, I should have cleaned this properly really first of all, shouldn't I? You can see there's lots and lots and lots of little teeth on there that act as a cam, and it's exactly the same thing. Exactly the same thing, where this will drive in this direction, but this will be able to rotate freely when the engine's started. It's exactly the same kind of thing. So what I want to do is I want to use this piece here. So I don't need that, I don't need that, I don't need this. The reason we choose an R6 Yamaha, this is off a 5EB version. But the reason we choose it is because this diameter here is exactly the same diameter as this diameter here. So what I can do is I can take this, and that will fit over there very, very, very nicely. Don't need that, don't need that. So what I'm going to do is I'm going to fit this onto here, and that will go onto there. It takes a little bit of time and effort and persuasion, not this time, sometimes it does, but there you go. I've now fitted an R6 starter clutch onto a CB1100R gear wheel. The next bit is I need to fit the spline onto this. The problem I've got there is that the holes don't line up. So what I need to do is I need to either elongate these holes or drill extra holes to suit. And that's going to be the next job. Okay, so here we are with the starter clutch. You can see here that I've extended the hole on this plate here. That's because this is an 1100 plate and there's these lightning holes here, so therefore I can't effectively drill 6 new holes in the outer plate to match up with the R6 clutch. If you have one of these, I would recommend that you do drill 6 new holes, because you have the meat around the studs to be able to use that. On this here I couldn't, because if I then extended all of these, I suppose I could extend these holes here and add an extra 3 bolts. I probably will do that, in fact. But on this you can just drill 2 either side of each of these here, and it has exactly the same effect. And that's it. You just then slip this back onto the crankshaft. Check that it works. Of course it does. So therefore it spins freely in this direction, and it doesn't drive in that direction. Perfect. Job's a good one. So R6 clutch on a CB 1100, 900, 750 starter wheel.